Welcome to my presentation on an ecosystem for the digital lab, key aspects and possibilities. My name is Freek Varossieau. I'm an application engineer and I'm supporting customers in the area of OpenLab CDS, the integration to LIMS systems and reporting. The subtopic for today will be integrating OpenLab CDS into your environment, in other words, into your entire laboratory automation. The topics for this seminar are quite simple. You will have a short PowerPoint presentation, an introduction. We're going to integrate OpenLab CDS with LIMS, and we have a middle layer for that called Sample Scheduler. We explain to you how it works, and we even show it live to you. And at the end of the live demo, we have a short wrap-up of a few bullet points, which repeats what we have told before. So, the short introduction. Now, we talk about the role of the CDS in the laboratory, and quite often we think that when you are in the lab and running your samples, you can get the impression that everything revolves around the lab, and in particular around the chromatography data handling system, as the chromatography data handling system can generate a lot of results that need to be put back into the systems. However, the laboratory and the chromatography data handling system is just another data provider for production systems like SAP or like a LIMS system or like any other particular production system out there. So in the bigger picture, from an IT perspective and from your operation perspective, the chromatography data handling system, your CDS, is just another granule in a large heap of sand. It is an important granule though, because we're providing a lot of information, and based on that information, production will be altered, will be steered by, and also particular results and batches and products will be released based on the results we provide. The other thing is just-in-time data providing. But the pressure on us today is to provide more and faster results, and yet with ever less people in the laboratory. Work is getting more and more, and we have less and less. So operators today, coming from the production floor, are now performing analytical tests on their own and expected to do that with less supervision. So they're on their own at night and there's nobody present. And in order to achieve such a workflow, solid investments need to be made to cater these new workflows and new demands. So the less people you have, the more you have to invest in automation and automated workflows. Less errors in transcription, another source of wrong decisions made. Manual transfer and double checking of results is not only time consuming, but also a source of errors. What is actually desired is that at the end of the analysis, an automated transfer after electronically checking the results is done. So we would like to have an electronic review of the data and then an electronic transfer of the results. Everything in specifications? Oh. The other thing is sample planning, knowing upfront which work is in the pipeline for you. In other words, which samples will be taken in the field. And knowing which samples are coming, it's day and night. And you also want to know which samples are cancelled. So running ad hoc samples and managing priorities upfront simply make life easier and prevents aggravation, as people are not surprised and disrupted in their daily work. There's nothing more irritating that you have to drop everything you're working on at that very moment and you have to pick up sample because somebody is banging at the door. And at the end, cost saving. So it's work smarter with less people. But what you also want is less workload on employees. And doing more with less is often hurting companies today. Lean organization. And with the increasing production and the leaner organization, in other words, less people on the work floor, the pressure increases on those individuals and they have to work longer and might be home later at the evening. That's not good. It's also a cost. People making extra hours to achieve what they normally do. And by choosing the right automation steps, reduction over time and workload can be achieved. Next slide. The integration of OpenLab CDS and sample scheduler. So what we're going to show you here is the ability to interface the OpenLab CDS with the LIMS system by means of a middle layer. It's called the sample scheduler. And the sample scheduler is kind of a roundabout where samples come in and results are coming out. So let's look at what we are facing here. So if we are looking at the traditional workflow in the lab, is that we have a laboratory information management system, irrespective of which one. It could be your home-stricken one, it could be a commercial one, it could be your SAP. That is having the sample information. And the sample information is sent to the field to collect the samples, and the samples then coming into the laboratory where users have to manually transcribe those results into the CDS. So this is transcription error source number 1. We have people working on sequences and single samples and sending it to the individual instruments by hand. The instruments generate the results, they are reviewed, and then the users are entering those results manually back into LIMS. And this is not a source of errors. The manual entry of results back into LIMS. It may be time consuming because those results might need to be reviewed by a second user or a second reviewer. So this entire operation here is this circle is quite classy. I see it a lot. And we still see it a lot, but it's also time consuming and error prone. How can we simplify by using sample scheduler? And that's the big question, and we depict in the next slide. So what we have is still the same LIMS system or your SAP system, and the same samples are still generated. But instead of having reports or pieces of paper printed out and sent to the laboratory, the LIMS either generates a task for the sample scheduler in XML format, or the sample scheduler on its own pulls the LIMS from the system. And those test requests are coming into the scheduler itself, where they're automatically dispatched to the various instruments. What is still required, of course, is that users are putting the samples into the tray, and when those samples are into the instrument trays, with a simple mouse click, the user activates and schedules the run so that the instrument actually works with the runs. The results are generated automatically, and then the results are automatically transferred back to LIMS, either directly or with an electronic review step. In both cases, there is no manual entry anymore. So this entire workflow is now simplified in steps that are automated processes. And the only way what we see here is the manual results entry is gone. It's automatically either being reviewed or not. And the manual work still is the sample prep and putting the samples into the instruments. Now, how does that look like on a real screen? And we see this little screen here. Where you go to enlarge this a little bit. This is the classic user interface. There's also a web-based user interface. And what we see here is the different samples that are running on different instruments in different laboratories, and what their status is. One is submitted, the other one is running, this one is still on its way. We have here an error system. On sample 5, it might be that something is wrong with the GC. The nice thing is, though, that you can now assign this job to another GC that might run the same method. So you would have a very nice overview from your desk, somewhere sitting in the office, of what is going on in the laboratory. Now, how does it work in this case? So let me explain to you this in two simple screenshots here. We have a LIMS system, and anything in orange is LIMS activity. Anything in blue is sample schedule activity, and everything in gray is the OpenLab CDS. So the LIMS generates XML files, as you can see here on the top, XML. And the XML files is dropped into an inbox for the scheduler. The scheduler has a LIMS agent running. It picks up the tasks sent out by the LIMS, put it in the database, and the CDS, the Chromator OpenLab agent, picks the task up and assigns that to the right instruments. In the LIMS folder, we export the results, and the LIMS agent picks up the results and put it back into LIMS. So this is again a closed loop system. So this is on XML files, and with XML files we cater many different LIMS systems, SAP systems, or whatsoever. But this is still file based, and there are plenty of pharma companies out there that say we do not like at all files that are being sent around. So what we'd like to see is that we would have a transparent interface between the sample scheduler and the LIMS database. And this is what we do here. Anything here in bright orange is still LIMS, blue is still the scheduler, and gray is still the chromatography data handling system. And what we have here is that we are picking up the work from the SQL system directly by using SQL statements in the agent. So the LIMS provides intermediate tables in the database, and the sample scheduler agent is picking this up using SQL statements. And then the same process applies. The scheduler puts it on the agent puts it on the instrument, and at the end, the results are sent back into the LIMS database. So that is, again, another closed loop activity. So what is going to be next? The next thing is a demo. How does this look in real life? So I'm going to close this PowerPoint presentation, and then we will look at the software. So I'm going to click on. So you have now a nice view of my PC, and what I have provided for you here today is a client server system. So I have here an ECM server. The server is both LIMS server as well as it is the OpenLab server, as well as the sample scheduler server. So 3 jobs in one system. And then I have an OpenLab client, which then is the sample scheduler client, but it's also running the instruments, and you get providing me the user interface. So client server in this case. Let me make this full screen so we can enjoy the entire resolution. And the first thing I need to do is I need to log on to the system. Now, what do we see on my screen? We see here, and let us focus first here, the control panel of OpenLab CDS2, where I have my instruments. I might have different laboratories, and in the different laboratories, I might have different instruments being placed here. And we're going to use the GCs from the QC lab, and we're going to use the virtual machine today. We can even probably use also the DHA laboratory if we have plenty of time to do that. And we also have here the sample scheduler, is a classic user interface, what we call FAT client, and it allows us to see which samples are being logged from the LIMS onto the sample scheduler. It's still empty because we're going to mimic that work, how that goes into the normal workflow. And on the other end, we have also the web browser, and the web browser shows me my instruments, and we're logged on here on that particular web browser as, I believe, if I'm not mistaken here, as John Wayne, which is an operator. And also here we have John Wayne in that case. Right. As I started my presentation and explanation how we can work between sample scheduler and a LIMS system, is that we can have XML files being provided by the LIMS to the sample scheduler to put into the system. And I'm going to mimic with my mouse how a LIMS works. So I have here a bunch of XML files. So I'm going to select them all. And the LIMS generates those XML files. They create the XML files and drops them into an inbox of the sample scheduler. So I'm copying the work over into my LIMS commands, and it's being there and it's being absorbed by the system. It's quicker gone than you think. Yeah, and I can even do that also for my DHA. And I dropped it in my LIMS commands and copying it over here. So I have a number of activities placed into my LIMS command. And what we can see here already on my web browser is that I have 13 pending samples to be done. As I already said before, is that I also can use my SQL statements to pull samples from the database. And for that, I need to feed my LIMS system with samples. And I can do this automatically here with a script that allows me to fill my LIMS database with samples that need to be analyzed today. So I'm quickly adding samples to my LIMS database, and that LIMS database will be pulled by the sample scheduler automatically. So let me make this smaller for you because we don't have any use for that anymore. We can already see that we have 14 samples pending in the system. And by just giving a simple click, as everything is interactive, I can see which has been all scheduled for me. I can add manually samples to it. I can search. I can select them all, for instance, and then I can assign them to myself as John Wayne. And then the user will be here as John Wayne depicted. I can delete if I don't want them. We see them, the status is waiting. I can also start them. What we can see here also, sneaky in the background, a sequence has been added, which is done by using the SQL statement, which is actually polling the database and auto-assigning it to me. And we have here blank system suitability injections, calibrations, and particular samples being added to it. So both activity has been working, the XML has been working, and the SQL has been working. And I can just select here my my samples, my entire sequence, and I can just start my sequence directly from here and schedule it. COVID forces us to work at home, and when you have a puppy, you will have a lot of noise. Here in the sample scheduler, we can have an overview of what is going on. We have our DHA, we have our GC, and we have our sample scheduler. And